All right, it's recording. All right, everybody. Hey, welcome. I'm Steve Lander, Director of Pavement Management for Withers Ravenel, and today's Lunch and Learn is solving your crack pop problem with an Aramid reinforced asphalt layer. That's a mouthful, but it's a great. It's great. I'll show you my sample that Tim recently sent me, and we'll be taking a look at that today. So hope everybody's doing well. And the intent of our Lunch and Learns is to hopefully broaden your toolbox of the different practices and maintenance activities that are out there. We suggest that you try some, and I think you guys are going to be real happy with this presentation and what it can do for your agency and your municipality and solving a crack problem, and a lot of it's environmental cracking when you have thick layers of asphalt. This is going to be a great presentation. So in the chat, we're going to be posting some links. The first link, and they just got posted. First one is if you need PDH credits, we're going to give one free PDH for this. We have websites. I got Withers Ravenel, Black and Ship, Surface Tech, and then there's a couple brochures in PDF format. So those are part of the links. And so if you need the PDH, just click on that and it'll take you to a website. You fill out the form, and when we're done, you'll be getting a PDH for that. Also, there's a section that anything that you think could be improved. Are there any topics that you would like for us to cover in future Lunch and Learns? That would be great to know. All these Lunch and Learns are recorded. So if you have to jump off, or someone you thought that might be useful, you can pass the link along to somebody, and also we can get you the presentation PDF format. All righty, so the format of our Lunch and Learn today is that Phil and Tim, and I got it, Phil and Tim, and Tim's really here to just keep us in line. He doesn't have a huge talking part, but he's going to interject as needed. So talking and presenting for about 40 to 45 minutes. Everybody's on mute. So what we would like to do is create like a conversation as much as we could. So when Phil is presenting, just ask the questions, and we'll try to address them as they come up. If there are a lot of questions, then we'll get to you after the presentation. We'll email them to you. All righty, so the introductions. So Tim Hobbs, he's a regional tech sales for Surface Tech and Ace Fiber. He's a graduate of Wake Forest University. He's got over 25 years of experience in dealing with bridge, concrete repair, and asphalt. Is currently an independent sales rep for dealing primarily with Surface Tech, Ace Fibers, and Zincotherm, if I said that correctly, anti-strip additives. Phil Blankenship is president and owner of Blankenship Asphalt Tech and Training, which is BAT. So there's going to be a Batman theme here in the back, right? He's a graduate from University of Kentucky, graduated in 91 with a BS and an MS in 93 in civil engineering. So in 2017, he founded BAT, and he's been involved with TRB, Association of Asphalt Paving and Technologies, ASTM, at various different capacities. So with that, I'm going to turn it over to Phil to get us started.
Thank you to everyone. Appreciate everybody joining us today, and we will be respectful for your time. Really appreciate Surface Tech for working with me and allowing me to be able to host today, and along with Withers. And with that being said, what I'm going to do is I'm going to jump in to talking about the interlayers and why we use them and what's going on. We've heard a lot about stopping cracks over the year, and what I have found when I started down this path, I didn't see a lot of good solutions when I started out in the industry in the 90s. I worked for Kentucky Transportation Cabinet in the 90s. I went on to work for Koch Industries, which is a refiner out in Wichita, Kansas, where I worked on the petroleum side, the asphalt supplier side, polymerized asphalt. That's where I first ran into this interlayer and the European technology behind it. Then I worked at Asphalt Institute under research, and the Asphalt Institute's where you see a lot of our educational books come from today, there in NCAT. After that, I founded my own business and realizing that we really need to reboot this interlayer. And the reason why is that we don't have a lot of great solutions out there. There's a lot of things that we hit and miss and we feel good about, or we'll put it down to make us feel good, but they really don't address the problem. A lot of times we go in and we just do a standard 2-inch mill and inlay to try to fix everything. And this really approaches the pavement side from a very unique perspective. And it gives a contractor a local solution. So with that, I'm going to dive right into it here. A little bit of background about the interlayer. Everybody has seen reflective cracks before. You put something down over a concrete pavement, and that crack, it's a mismatch in materials, especially the transverse crack will come right through. What I have seen is the cracks that happen naturally in the concrete, they tend to be at an angle and you get a little bit of a resistance to shear. But once we intentionally saw cut and put the dowels in, we create that area that allows that pavement to move. And what some states have gone to is complete reinforced pavement. Very expensive, very effective, but very, very expensive on the front end. And also when it's time to tear out, it gets very costly. So what do we do with all these pavements that are out there with dowels? The largest one I've seen was in Oklahoma, where they had 80-foot long slabs with over an inch of movement at the joint. That's what we're trying to target. And then what happens is we can handle a little bit of the back and forth movement, but when the dowels begin to wear out and you begin that joint to move up and down, that's the trick. And that's the part where a lot of these materials are just not made to attack it. We have a lot of materials that try to address this, but we're not addressing the up and down movement. You cannot do that with a thin material. The thin material is good, whatever it may be, grids, chip seals, and so on, SAMIs that you put down, but you're going to have something that's going to address this. In the early 1990s, asphalt interlayers were used with varying levels of success in France. They call them sand anti-fissures, or SAF. Companies like Scrag and others in Europe were using these. When Koch Industries, at that time, Koch Materials Company, which they sold off all their plants in the early 2000s after 9/11, they saw this technology and said, this is something that we need to implement in the U.S. So I spent about 10 years of my life working on this. And what we came up with was finding that if we use a high asphalt mix like they had in France, it's a small mix, a number 4 mix, place it about 1 inch thick. It's going to be impermeable, and it's sure a different approach. It looks very different in that instead of it being an aggregate that we fill with asphalt, it's an asphalt layer, a liquid asphalt layer that we fill with the aggregate. If you've never seen what pure asphalt looks like, this is it right here. And and I can push in on it and I can make it move around, and you can see my thumb imprint in it. Then it will eventually pop back out. So what they did in France was they figured out that we could do this with this type of material that I could really push into, and I could use a lot of polymers in it. And by using a lot of polymer, I could get a rebound, and it really worked well. Again, we're targeting that area over the crack that by putting down an inch. So think of this as close as you can get to almost like an inch of pure rubber of trying to do a stress absorption or a dampening layer, or putting a shock absorber in between the concrete or the cracked up asphalt pavement and the surface over top of it. We found that we have to absorb about 80% of that movement. And I'm talking about the shear movement. The lateral movement's easy. The shear movement is what is difficult. So we had various levels of success because we found out it worked in some areas and not in others. What we realized is that we need to climate adjust this material. And so by 2000, I dove back in the laboratory after a couple of years of just trying to adopt what they did in France, and we began to do that. We looked at site reviews, thicknesses based upon traffic. We created a performance-based spec using a beam fatigue device that's actually bending the layer back and forth. We created a rutting component. 2002 through 2006, we then worked with University of Illinois. At that time, Bill Butler was there, and again, a guy named Ishan Dowie, who is, it looks like D-A-V-E, Dave, but that's actually Dowie. And he's moved on now up in New Hampshire, and Butler is down in Missouri. But at the time, we assembled a team under the National Academy of Science. They called it a National Science Foundation GOLI, grant opportunities with academic and liaison in the industry. With that, what we were able to do was create even newer tools to help identify how to design these pavements. And they went and modeled it, and they put down large scale, and they really found out what we already knew, but it had to be confirmed to actually be able to put the strain gauges in the pavement and find it. 25 years later, as with any good technology, it was different. And when the company went away, when the champion went away, why adopt it? Let's go back to what we were doing. 2-inch mill and inlay, we'll go back and just replace it every few years. Some states were replacing, I think on Pennsylvania Turnpike, replacing it about every 5 years. And a lot of these states were saying, could we do something? Can we actually extend our pavement life? We didn't have a lot of data back then. And so again, adoption slowed down due to lack of understanding. The asphalt supply, this liquid that I was showing you, went away except in a very small region out in the middle of the US. Today, the interlayers are still intact. The one that I put down in 2007, just north of me in Lexington, had an overlay put on it. It was milled down to the overlay in 2017, and they put another overlay on top of it. And today it's still performing, and you would never know that there's concrete underneath it. Why is that? Because it's offsetting the crack that comes up through, but also the crack that eventually comes up through is very minor, and you've got a water barrier that's keeping the base protected. Today, the problem is, what do I do if I can't get this liquid anymore? Well, we found out that by using a light polymer, let's say a 6428, a 7028, in the hot areas, a 7622, I can go and I can use Aramid fiber. Aramid fiber is also polymer, just in a different form. Aramid fiber is also known as Kevlar. And by using these long fibers, what I'm able to do is it's a heat resistant fiber that goes in. And we found out in the 90s that fibers worked really well in pavements. But when SuperPave came online, we sort of forgot about the fibers, and we went back to the basics of asphalt and aggregate, asphalt and rock. So back then, they were using things such as pan fiber. The pan fiber was a really short fiber, polyacrylic fibers and PET fibers. Do not confuse them with this stuff that looks like carpet. This is cellulose fiber. Cellulose fiber is very different. Cellulose fiber is meant to be a sponge, and that's used with our modern with our SMAs. SMAs have to have a sponge in there to keep them from having drain down. This fiber that I'm showing you, the Aramid fiber, does not absorb asphalt, does not change the mix design. It is a structural fiber that does improve the structure. It reduces cracking, reduces rutting, again, without a change to without the mix design. One of the things that I found was that fiber itself greatly improved the fatigue life. So when I married the fiber to the interlayer, what I got was a product that I could twist, and it reminded me of my old interlayer that I was able to use. So now we're going to reboot this technology. I want to go through and show you some early examples of what we did and then what we're doing today. This was a project in I-94 in Racine, Wisconsin. And this one, there's actually a TRB paper that's associated with it. So that's why I'm actually mentioning it here. In this case, they were going to use a 1-inch interlayer. They did a V-mill on the longitudinal joints, which they found the V-milling technique worked really well to help them control the longitudinal joints to get rid of the old material. And then we put the interlayer on top. The interlayer is very fine, so it will go down and fill those joints. What was required on top was actually 3.5 inches for this traffic level, but they'd gone ahead and planned on putting 4 inches of the super pave mix on top of it. They put that, I think, in two 2-inch layers, and that helps them with rideability. Over on the other side, they actually left a control where they just had 5 inches. They did a 3-inch layer and a 2-inch layer, I believe. This was after about 3 years, and it was looking good. And what they found out early on when the DOT was looking at this, and I apologize, I don't have more data on this one project, but I was not able to get back on it just because of the high traffic volume. But like any great research project, it was tracked for 3 years, and then they were done with it. Hey, they at least tracked it for 3 years, right? Some you don't even see that. And I'm going to show you some that we tracked longer. But on this one, when they saw what they did see was that the interlayer was showing less cracking. Now you got some noise that will happen in here, but overall the controls were coming up with their normal. I normally see cracking after the first year come back at about 25% reflective cracking per year. Some people say 1 inch of pavement per. You'll delay the cracks 1 inch per. I'm going to get it right here in a second. You'll delay the cracks
per year.
1 inch per year. That's sort of after the first year, Steve. Yeah, thank you. I just couldn't get it out, man. What really happens is it's not that you're delaying them coming up like that. It's some will come through faster than others. And really what's going on is you're delaying at about 25% a year, which works out about 1 inch per year if you're dealing with about 4 inches. If I'm dealing with a thinner pavement, again, I'm going to see about 25% of those come through a year. It just depends on how many cracks you're dealing with. When I use the interlayer, I cut that in half. So you could say that the interlayer doubles the life. I don't think that's probably a fair way to do it. It doubles the cracking, or it doubles the cracking resistance, but it may even help preserve the overlay even longer than that. Again, depending upon what you're trying to do, and there's a lot of factors with skid resistance, water intrusion, and rideability. It does greatly improve the ride, so that's something to consider too. When we went to go get cores out of this pavement, I knew what we were getting into, so I'll show you what happens. We go to get a core, and we took a core from the control section. Hard to see, but there is a crack that's going all the way down through here. It's very small at the bottom. It opens up at the top. And by the way, it was right over a joint, directly over a PCC joint. When I went to get the crack here, now notice you did get a crack, and eventually all cracks will come through. I want you to look at the severity of this crack as compared to this one. This was very typical. And by the way, you're really not seeing this hairline through here. The inner layer is intact. And by the way, the joint is about 1 to 2 feet ahead or behind where you took the core. Because what's happening, the crack hits the inner layer and it diverts it through the inner layer. That inner layer, imagine if you were to, let's say, paint a rubber band, and then you're going to stretch that rubber band. The rubber band is still intact, but you're going to get these little micro cracks across the top. And that's what happened here. But again, we get this movement that's going to happen up and down, and it's sheared, but it's way over to one side. That's why it's important to also treat the overlay if you can. And so we got rid of 80% of the movement that was estimated. We just need to be able to handle the rest of the 20%. A lot of our overlays today are stiff, as you know, and we're working really hard through balance mix design and terms like that that's used today, performance testing, to improve our overlays in asphalt. A lot of the biggest changes in asphalt specifications that I've seen in 30 years are happening now. So Coke was that old company, and it's not, while I like this, it is not this Coke. It is the Coke that is KOCH. And what they did was we put a section down in Iowa. Why Iowa? Decorah, Iowa is absolutely in the middle of nowhere. But what we did was it's in the northeast corner of Iowa, and it's a Minnesota type of climate. And it gets very cold, minus 34, minus 40 weather. And so we put the interlayer down. And what I did, this is 4 years later, I went to this control section and I stood in the middle of the road. I had traffic protection and I wanted to take this picture. It was a very unique picture. I snapped the picture in this straightaway of the section where the control is. And then I did a 180 and I took the picture on the left. Can you see a difference? This is not a side by side. This is an end to end. Same traffic, same climate, same base, and you get that much cracking delay. What I was impressed with was that the one on the right had treatable cracks. The one on the left, I'm sure there was a crack or so in there, but you really couldn't see them, and there was nothing to treat. That's my textbook example. Today, what we're doing is we're using that same interlayer, but we're using the Aramid fiber. And the reason I know this works is we're using performance-based specifications, and I'll show you how we're doing that here in just a moment. We're using more performance-based to design this interlayer today. I always said that this interlayer, if you could figure out a material to put in it, whether it's bubble gum or whatever you want to do to put it together, or some other polymer system, as long as it will pass the performance-based specs, it will work. It just happens that asphalt is usually the least expensive material that we have, because asphalt is simply the waste that comes from a refinery, and then we get it and we have to rework it. Palmer Engineering was the designer, and Hayden Materials was a contractor on this job in Taylor County in 2019. As you see here on the top right, you had signs of what they called micro cracking. I really don't know if that's the right word, as much as it was raveling. You could definitely see water. You saw stuff percolating from the bottom, and our mix was dry. And they said the problem is we had a treatment that only lasted about 6 years for a runway, and they don't have that much money to go repave runways every 6 years. This should have lasted 20, 25 years. So what do? And they said, we want to stop the water. We want to put a barrier down. We know we could have used a Sammy, but we really want to try the interlayer if we can make it work. At that point in time, we could not get the one asphalt supply. I called the folks at Surface Tech. I said, I want to try something. I want to do this with Aramid fiber. They said, sure, we'll set up to make that happen. And we were able to do that in 2019. They put a 2-inch super pave overlay on top of it. The project was awarded an ASCE, I've misspelled that wrong, I'm sorry, ASCE, Kentucky Engineering Excellence Award. And it is now eligible to compete in another excellence award. I don't really know what happened on those awards. All I know is the runway is really working well today. I want to show you just a few pictures from that to let you see what it looks like and how it actually was constructed. So when we look at the mixture, you see this is a very fine mixture that goes down. You can see the fibers. That's the little things that's dangling down here on the pictures. The fibers are so small. These are about 10 microns. So your hair is probably 50 to 80 microns. These are 10 microns. And that's what's holding this together. But those fibers are stronger than steel. This is the 1 inch of material. Now, naturally, when you think about an asphalt layer, and we're going to talk about the materials here in just a moment. When you think about an asphalt layer that is 8.5% asphalt, that's made of fine material, you're going to say, oh my goodness, what's going to happen when I put a roller on top of it? And the answer is, it looks really good and it just compacts. Let me let you see that. So it actually, instead of compacting a lot, it actually get a lot, as far as under the roller, you get a lot of the compaction behind the paver, and it will then compact about an 1/8 inch per inch. Or if you're in the metric system, probably about 3 to 4 millimeters per 25 millimeters. You can see it going under the roller there. It is not even moving underneath the roller. And this is a mix that has 8.5, maybe 8.5, 8.6% asphalt in it. We're looking for about 96 to 97% density in place. On average, at the time that I left Coke from Wichita at the end of my tenure, we had reported, and we were following a lot of projects. We reported an average of 71% improvement in reflective cracking on interlayer projects as compared to a control. That data represents up to 18 projects over 4 years old. Somebody said, why didn't you track them longer? Well, I had to earn money for my family and I had to move on. But I do agree, absolutely, they should. It would be great if people would track these projects. Today, I'll tell you this before I move into it. I know that the state of Wisconsin today continues to use the interlayer. So does the state of Kansas. Iowa has stayed true to what they're doing. And why is that? When you look at those areas out in the Midwest, there's a lot of concrete pavement. And so they continue to use that interlayer. Texas developed their own version called a crack attenuating mixture that's similar to this, but it just has less asphalt and higher air voids. It doesn't do as good, but it does what they feel that they need in Texas. Let me give you a mixed design example for those who love to dive into the details. This is one right now. The area just north of us in Canada is going gangbusters with this product because of the crack reduction. We're going to go put several down in Canada this year and next year. This is an example. Typically, I'm using about 3 bins. In this case, they're going to use 4 bins plus their baghouse fines that they'll add back in. And what we end up with is, and we're going to use a double dose of Aramid fiber, or we're going to use 4.2 ounces per ton, and that's the pure Aramid. There's a wax. Let me show that here. The fibers are delivered, and they look like matchsticks. They have a wax coating that will actually go around them, but that adds about another 1.2 ounces per ton. But I'm talking about just the pure Aramid. Once it's released and gets into the mixture, that's what we're looking at about 4.2 ounces per ton. If you look at a gradation of that mixture, it is fine. The red line represents a max density line. Typically, most mixes we use today are a 3/8 inch mix, a 1/2 inch, a 3/4 inch mix that you'll see typically 1/2 and 3/4 on airports. You'll see these mixtures that will gap and they'll go down through underneath this red line. This one is way above it because we're going to reduce permeability. And this is also considered a hydraulic type of mixture. And it goes way above this line. And it is absolutely impermeable. When I try to understand why I use the Aramid fiber in there, well, it's, again, I mentioned before, it's non-absorbative, it's high strength, it has a high melting temperature, it has really high modulus. So that really fits well for what I need to make this work in reflective cracking. If I think about wearing a bulletproof vest, the bullet's going to go into the vest and it hits this material and it bends it not very far because it doesn't pull far, and then of course it rejects the bullet. In this case, it's going to try to crack it, but it's going to resist that crack, and that's how we make this interlayer do what it does. You're probably thinking, well, could we also use the Aramid fiber in the surface to help it be crack resistant? Absolutely. To fix the severe cracking problem, you've got to use the combination of materials. Again, one size doesn't fit all. Any amount of fiber will help, but using these type of material combinations is the answer to really fixing a cracking problem. The Aramid itself is specified by ASTM 8395. This is what it looks like on a bad hair day, or when you actually split it up and begin separating it and getting ready to put in a mix design. That mix design on the optimum design volumetrics we're looking at here of about an 8.5% mix, 1.4% air voids. If you look at the other parameters, these are all, if you want to see the GMM, the GSE, the GSB, and folks, I do all sorts of trainings on this stuff. I do Asphalt 101 training. I help folks with commercialization. I get into asphalt innovations. I think I get to do that one next month. But we could dive into all of this type of data. But for today, those that like to look at this, this is a 50 gyration mixture. It has a air voids of 1.4%, or if you want to think about it, it's 98.6% dense in the laboratory, over 20% VMA, and I fill those voids with 93% is filled with asphalt. So this is an absolutely loaded mixture. You'd normally see this number 65 to 75. We're up at 93. When I go to the lab, now I want to run a performance test. So I'm going to take a sample that I make in the laboratory. I'm going to put the sample on end, and I'm going to run what looks like a TSR test on it, but it's actually what we call an ideal CT test. And we're going to squeeze that sample between these two plates, and we're going to measure what's going on. And by doing an indirect tensile strength on it and post-analyzing what's going on the back end of the curve and looking at the slope of it, we're able to get a pseudo energy. And that's why this test, ideal CT, has become very important in our balanced mix design testing regimen. And a good mixture, and I mean a good one, would have a value of 153 at 25C. That's conventional. If I go down we just tested one from Arizona. We've tested mixtures from Florida. They're running in the 30 range, and they're happy with that. If I'm in Alabama, they may be running in the 50 range on that number. If I'm coming north, you're going to see it start to climb. In Texas likes a number of about an 80. If I come north where I'm at, Kentucky's wanting to move into the 100 range. So this is an exceptional mixture at 153. When I tested my interlayer at the same temperature, 25C, using this binder with double fiber, look at the number I got. Now, this is where I get to brag a little bit. I don't know of anybody else in the country hitting these numbers on ideal CT. This is 10 times what you would normally see on a hot mix, if not more than that. And that's because this is designed to do that very thing. This is not designed to run a lot of traffic on it. You can run traffic on it for a couple months, but it's designed to be an interlayer, and that's what this is. We also developed versions of it if I wanted to look at a cold climate, such as 15C, or a warm climate, like maybe if I go where I'm at here in Kentucky or a little further north, that would have a number, let's say of 20C. I'd use like a 6428 grade. So what I've got here is, this is sort of a spec I've come up with, trying to normalize this a bit, and maybe these numbers need to be 15, 20, 25. Right now, I'm trying to sort of follow along with what the standards recommend and sort of trying to look at this, but I'm not using a 700 value. Notice I dropped to 300, and that's because I'm making these at a different air void level. These were all made at 7% air voids, and that's a whole nother story. So this is what the end spec's going to look like, where we have a cracking test and a rut resistance test that's put on it using the Hamburg wheel tracker. So the advantages of this interlayer that we're using, just to recap, we're going to significantly delay cracking. It is impermeable. You are not going to get water through it. Matter of fact, I've done tests on it. Vapor will not even pass through this. It can be designed to allow that, but it's designed to keep even vapor from moving through it. We have a generic performance-based spec. If you can make it out of bubble gum, power to you. Updating with newer tests such as DCT, Ideal CT, Hamburg, and things like that. You can mill it, but more importantly, you can leave it in place and let it be a perpetual interlayer, which that's what it's designed to do. And they've been left in place across the U.S. Using standard hot mix production and construction methods. Matter of fact, you're getting rid of materials that contractor are dying to get rid of, such as a lot of their fines. So we're using locally available materials with the contractor. I always said contractors love to, so don't take offense at this if you love the grids and fabrics, but contractors would much rather be placing hot mix than laying carpet. Just saying. It is quick construction time and return to traffic. I've put down Sammys and you have to wait. You cannot run traffic on them, or you shouldn't, because you're going to get gravels popping loose. This, you can return it very quickly to traffic. And as far as that goes, it's about the same cost or a little less than what a grid would be. I know that's going to come up on what the cost is going to be. Costlier than a Sammy, usually same or less, usually less than a grid. And if you look at the traffic delay that you've got with the Sammy, you would much rather have this. Site selection. The RCRI, reflective crack relief interlayer, is about doubles the life of a pavement. I'd like to say that, and it could even be a little bit more. It really depends on the severity and what you have going on. We're going to place it on concrete or asphalt. It works very well, complementary with an overlay that's got advanced crack resistance. The PCC joint transfer, I like to see a 70 load transfer or better. If we could get that. I know that's not always desirable, and you go in to do a repair of a pavement and you run out of money, and you've got what you've got, and you have to move over it. And so the nice thing is the interlayer, again, will improve whatever it goes on top of. It can be used over crack and seat, but you'll need to level first. The interlayer will knead into large cracks or joints. Keep in mind that joint seals may bubble through, because this is an impermeable layer, just like you may see tack bubble through, but it really does not affect the performance. And personally, I like to leave a little asphalt over the concrete if I'm milling, or use a leveling course. And that way I don't have to go directly on the concrete. It also helps to eliminate any water bubbles that may happen in there. We like to avoid trapping any moisture, or paving after the rain, because the interlayer is impermeable. So if you have an immediate rain, you need to let the pavement dry off. As far as the overlay, this is what I came up with years ago, and it's based upon rutting tests that were run in the lab and tied back to easels. I've always recommended, and by the way, I have never had an interlayer to rut. Out of the 25 installations I've done, none of them have ever rutted. If I'm dealing with extreme high traffic over 30 million easels, I would at least use 3.5 inches. You see there, 10 to 30, I would use 3. Going all the way down, if I'm under 3 million, you could get away with about 1.5 inches over top of it. Concerning construction recommendations, only steel wheel rollers are going to be used for compaction. Don't want rubber tired on this, and we don't want to put them in vibration mode. You just don't need it. Interlayer will go down very smoothly, and with a static roller, it'll roll right over top of it. Density of the in-place mixture is a minimum of 96% of the maximum gravity. We're going to go and roll the surface to 1 inch thick. So typically they're going to put it down about 1.25 inches, 1.1 inches, and it will roll to 1 inch. And then you can release to traffic within about 5 days of placement, and you can open the traffic after it's cooled to less than about 150 degrees, or whatever your normal specs would be. Maybe it's 160, maybe it's 140. You should cover it. I like to cover it within 5 days of placement. In an emergency situation, you could leave it open, but keep in mind it's impermeable. Water's going to sit on the top of it. You got to have your road signs up, because it would be slick if you had a rain on it. Again, it's made to be an interlayer, not a final surface. And you would tack underneath the interlayer, and you would tack over top of the interlayer, just like regular paving. a few references if you wanted to look those up. And I've got some other papers that we've recently written, done quite a bit that's being published, like I said, up in Canada right now. And trying to think where else. The Transportation Association of Canada and the Canadian Technical Asphalt Association, CTAA. With that, I am done. Looks like probably about 3 minutes early, and we're going to open it up to questions and see what you may have. I'll leave this up on the screen here for just a bit, then I'll shut this off, and so we can see everyone.
All righty. Any questions for Phil or Tim? I'll tell you, for me, I think it's this is great, you know, because a lot of municipalities, and we deal with municipalities in North Carolina, in Florida, South Carolina. You know, a lot of them don't have the concrete pavement, but they've done a lot of asphalt overlays, and the overlay, and all that environmental cracking has come up through. So, you know, you could use cold in place recycling. In Florida, cold in place is in full swing there, but here in North Carolina, the asphalt industry is not such a big fan of them coming in here to do that type of work. So with having this interlay, you can have any contractor put it down. So it's not specialized equipment. It's, you know, it's not a new practice that's trying to get into into your area. So anyway, that's the big positives. And trying to stop the reflective cracking, because other than that, you know, you're looking at having to mill out everything. You know, some places 7-8 inches of asphalt and going back, and there's all sorts of problems that can be encountered by doing that. So cost per square yard for 1 inch is a question.
Yeah, that per square yard, I'd have to calculate that. It's running. What's your hot mix running right now, guys?
So yeah, per ton, you know, like we're 110, 140. It depends upon the size of the project. Okay. The smaller is more 140.
Yeah, this is going to run on these smaller projects, and especially because you've got the newness factor. You're going to be looking at probably about 200 a ton is what they'll be doing until they get used to it.
Yep. Once they get used to it and everybody's doing it, then it's
that's exactly right. And you can convert that over. I did not do it, but you can convert that over to square yardage.
Exactly. You know, and one thing that we do when we're ever talking in square yards, because that's, you know, when you pavement condition survey, the length and the width, and but it's got to be an all-in cost, right? So
that's right.
One thing that Rob Holland and I like to talk about, and folks haven't been talking about a lot, is the curb and gutter and replacing ramps. And, you know, Cary, North Carolina, they have about $315 million in their curb and gutter. And so they have a program where they're actually replacing it as they're doing their overlays. And so anyway, I say that when we're talking about unit costs, make sure that your unit costs include everything, you know, out the door. What does it look like? And, you know, how much does it cost to pave a road? You know, milling, raising valves, you know, building ramps. So that's really important when you're trying to tell the story of how much it costs to do a particular maintenance activity.
Yeah, and you know, you were talking about just, you know, fiber in general, just to give you an idea. Now the interlayer is at a different level, but what I found when I'm seeing fiber go in on airport projects here, they're doing a lot of it on our GA airports and so on. Fiber has increased the mix cost somewhere about 10%, but if you look at the overall project cost, it's usually less than 1, and you got to look at that whole.
All righty. Any other questions? Do you have standard spec sheet you could share? Yeah.
Yeah, we've got one that we just recently reworked for the Pennsylvania Turnpike Authority. So glad to share that. It would need to be adjusted based upon your climate and where it's going to be going, but I've got a generic one I could share.
Okay. Any we had two. So I guess Phil, you could you can email it to me, and then I'll get it out to our participants. All righty. Well, I guess that's it for questions. And and PDH. Okay, that's listed. All right. Well, thank you, Phil and Tim, for joining us today. We're certainly.
If I could add, please,
Yeah.
if you have questions and need answers or need some direction, please feel free to give me a call, and I'll get you in touch with the people that you need if you want to follow up and get more information on all of this. So I'm the sales rep, so I'm used to the phone calls all the time. So I always answer the phone.
So, you know, one of the things I like to tell folks who present on these is that anytime that we have a project that's going to happen in the area, it would be nice to have a lunch and learn where we go out in the field and, you know, maybe grab some sandwiches and watch it go down and talk through, you know, any of the questions you have while you're out in the field. And we have been trying to set up for the last couple of weeks a roller compacted concrete project, and a part for the plant broke, and they didn't get the part last week and they didn't get it this week. So anyway, so as is with construction, things don't always go the way we expect. But anyway, so Tim, if you can let us know when projects are going to take place in North Carolina or other areas, that would be great, so folks can get out and see it. So folks are thanking you for the information. Thanking. Very informative. Anything else, Tim?
I think Phil's done a great job of explaining it. I hope it was very useful to everybody. It's something we really need to take a look at.
Yeah, absolutely. I'm excited for our clients and getting started and using this. This is definitely going to be a helpful tool in the toolbox.
Well, I appreciate you all allowing me to present this. It's incredible technology. We've, you know, as far as the East area, they've done some up in the Northeast, very little in the Southeastern U.S., and it's just waiting for a home, folks.
Yeah, it's awesome. I'm really excited and it's like, it's kind of funny is that a lot of the stuff is not really new, but it's new to us, right? It's new to the area. And so breaking them in and having your first job and doing it and keeping an eye on projects that are done to see how it performs. I mean, what it boils down to is the dollars per square yard year, you know, so what is it really working for you over time? All righty. Well, appreciate everybody coming out today. Phil, thanks for presenting. Thanks, Tim. Our next Lunch and Learn is in May, on May 29th at 11:30 a.m. And Phil, our Batman, he's going to be presenting on asphalt testing and performance innovation. So you got a double header with Phil talking about asphalt. So anyway, May 29th, 11:30 a.m. You'll be receiving the emails. Thanks again and have a great day.
Thank you all. Bye.
Bye.